Hey guys, I wanted to talk to you today about testing concavity on intervals created by discontinuity. Here's a rule. If a graph is discontinuous at a given value for x, then you have to check your concavity on each interval created by this discontinuity. Okay? Let's take a look at this example. I've got f of x equals x over x minus 1. Now, I know that there's a vertical asymptote created at x equals 1, right? So, if I looked at this graph, and I'll show you this now. I've graphed this out. Here's what that graph of x over x minus 1 looks like. As you can see, there's a vertical asymptote right here at x equals 1, right? Okay? Now, looking at this graph, again, to the left of x equals 1, it looks like this graph is concave down. It's opening downward. To the right of x equals 1, it looks like this graph is opening upward. So this looks like it should be concave down on the interval from negative infinity to 1 and concave up on the interval of 1 to infinity. So how can I do this? Well, to test my concavity, again, what I'm going to do is I'm going to take this second derivative, right? That second derivative is used to find concavity. So I'm going to go f prime of x equals, and I'm going to take the derivative of that. So here's the first derivative. You guys can work that on your own. And now here's the second derivative. Now, if I take this second derivative, this is my tool to test for concavity. Well, the first thing I'm going to try and do is I'm going to try and use this tool to see if there are any points of inflection. So to do that, don't I set the second derivative equal to 0, and I solve for x. But wait a minute, when I do that, would you agree I just get 0 equals 2? So this doesn't point me towards any type of concavity or any types of points of inflection. So the second derivative doesn't produce any points of inflection for me. So now what? Well, again, using this rule, I still have to test on each side of my discontinuity. In other words, my vertical asymptote in this case. Again, I know at x equals 1, I know I have one branch that looks like it's concave down, and to the right side of x equals 1, I have a branch that looks like it's concave up. So I have to find out the concavity using the second derivative on each side of this vertical asymptote. So let's go back. Now I'm going to go ahead and erase this. And I'm going to take this vertical asymptote value, this value that makes my function undefined, and I'm going to put that on a number line for f double prime. So I put 1 on my number line. I now pick a number to the left of 1, say 0, and I test that number in the second derivative. By doing that, I get 2 over, let's see, that would be 0 minus 1 cubed. Well, that becomes 2 over negative 1, so negative 2. Well, that means that the second derivative at 0 is equal to a negative value. Well, again, if you think about that, if my second derivative is a negative value, that must mean I'm concave down here, right? I must be concave down. Looking at the graph, you can see that I am concave down to the left of x equals 1. Now, picking a number to the right of 1, say 2, plugging that value into the second derivative, I get, well, let's see, that would be 2 over 2 minus 1 cubed. Well, that's just 2 over 1 cubed is 1, so 2. Well, again, that's a positive value, so I know at 2, my second derivative produces a positive value, correct? Well, that must mean, by my rules, that that's concave up, right? So now, that's how you can test for concavity around a discontinuity such as a vertical asymptote. I hope this clears things up a little bit. I'll talk to you later.